Applications of sinusoidal functions, basically your sine and your cosine functions, is what we're going to be talking about today. You guys are going to learn how to apply your skills, your properties, your features of these different sine and cosine functions to model real life situations. That is what we're talking about today. So all those concepts we talked about before break, how to find the amplitude, the vertical shift, the period of phase shift, all that's going to come back into play with today's lesson. Okay? That packet, it is a packet because it's pretty much all examples because you already have all the notes. Okay, so that packet I've handed out, that's what we're using today. That's what we're going to be working with today. So, when it comes to modeling these real world functions, it's easiest to write a cosine function to model this. The reason why it's the easiest to write a cosine function is because when it comes to a phase shift, it's easiest to find the highest point than trying to find where the curve crosses the midline. It's a lot easier to find the highest point. We're still going to need to know our big information, our amplitude, our vertical translation, vertical shift, horizontal translation, phase shift, and our period. Okay? So, what were those formulas again to find the amplitude? What do we do to find the amplitude? Max minus min divided by 2. How do I find my vertical? Max plus min divided by 2. Remember, your vertical shift was also known as your midline, okay? Like how high up, how down low did the graph go? My horizontal translation, aka my phase shift, what was that formula? Negative C over B. And then our period, what was the formula to find period? 2 pi over the absolute value of B. Yes, okay, so you're still going to need all 4 of these formulas when it comes to modeling, okay? Now, if very random, if it does ask you to write a sine function, okay, realize your sine function has the same amplitude, the same vertical shift, and the same period as your cosine function. However, to actually find what that horizontal translation, what that phase shift is, it is 1/4 of the period to the left of the cosine curve. That is always what the phase shift is for the other function, right? So let's say you found the sine function easily, no issue. Well, to get the cosine function, the A, the B, and the D, they all stay the same, but the C is always 1/4 of the period of that particular function to the left. To the left, which means you would need to subtract it, okay? So you'll see in the examples that we go through, we actually will write one sine function so you can see how it works. But most of the time, we're going to be writing a cosine function. So let's look at an example here. Okay, we're going to use this information to the left to write a sinusoidal function that models the number of hours of daylight for New York City as a function of time x, where x equals 1 represents January 15th, x equals 2 represents February 15th, and so on. So we're going to write a model. Then we're going to use that model to estimate the number of hours of daylight on September 30th in New York City. Okay? Well, if January 15th represents 1, February 15th represents 2, March 15th would represent 3, September 15th would represent 9, so September 30th would be what? Don't overthink it. Say again? 9.5. The reason why is because January 15th, February 15th, March 15th, April 15th, May 15th, June 15th, so on and so forth. All those are going to represent your whole numbers. Well, September 30th is the last day in September. It's halfway between September 15th and October 15th. Halfway would be 9.5. Okay? So once I figure out what my function is, to actually figure out the number of hours of daylight on September 30th, I'm going to take that 9.5 and plug it in. Okay? But I need to get my equation. First, okay? So, like I said, the easiest type of equation to write is a cosine function. So we know we're going to have y equals some number, cosine, then the rest, right? And we are going to do it with without the the B factored in. Okay, so we're going to have the B on the outside, the C, the phase shift itself on the inside, and then we're either going to add or subtract whatever the D is. Okay? So, let's figure out A. Okay? Let's figure out A. A represents my amplitude, so I need to use that formula. What's the formula? Max minus min divided by 2. I need to know what my maximum number of hours of daylight is and my minimum number of daylight hours, and then divided by 2. Now, this is an estimate. So, of course, as you can tell by the hours of daylight, they're not symmetrical, okay? But that's fine. It's an estimate. Looking at your hours, what's the largest number of hours of daylight? 15.07. So that's my max. What's my smallest amount of hours? 9.27. So those are the numbers that I'm going to use to find my A. So I'm going to have to do 15.07 minus 9.27 divided by 2 to get my A. What'd you get? 2.9. I'm 1/4 of the way done. Okay? Since I know my max and my min already, it will be the easiest thing to find D next. D is my vertical shift, so that's max plus min divided by 2. So now I'm going to add those two values, divide by 2 to get the N. What you get? $12.17? All right, 12.17. Okay. Questions on how I find A or D. So I scan through my data. I find the largest value. I find the smallest value. Now I need to find the part that affects my X is my B and my phase shift, my C. Okay? So remember, with the way that I have it set up here, I just need to figure out, whatever B is, I can figure that out. And then remember, cosine function to find that phase shift, which is right here. Let me actually write this as phase shift. Once I figure out how long it takes to reach the maximum, that's it. I'm done. I don't have to do anything else. Okay? So let's find my B. My B is a part of the formula for period. Period is equal to 2 pi over B. I need to look at my data and determine what my period is. Now, your period is the length of time it takes for a curve to complete one full cycle. Okay? Now, you might be tempted to say, oh, well, it represents January through December, so then the period has to be 12. Got to be careful of that. You need to make sure you look at your data and always base it off of your max and your min. How long or how many months does it span from max to min? So our maximum value is at June. My minimum value is at December. That is 6 months. That is half of a period. How do I get the full period? What do I do? If this is half of one period, how do I find the full period? Multiply by 2. What's 6 times 2? 12. Now in this case, yes, it will be 12. 12 months, I know, but not every one that deals with the months will be 12. You have to base it off of the data, the maximum value and the minimum value. So, because the period is 12, I set 2 pi over b equal to 12, and I need to solve for b. I can either put this over 1 and cross multiply, or I can multiply both sides by b. Doesn't matter. I'm going to end up getting 2 pi equals 12b. Divide both sides by 12, and b is going to be equal to pi over 6. Did you guys get pi over 6? So then b is going to be pi over 6. I am 3/4 of the way done with my actual equation. Now the last thing we have to do is we have to figure out what our phase shift is. Now again, the way I have it written, I have the b factored out. With the b already factored out, all I have to do is find how long it takes for my graph to reach the maximum, the highest number of daylight hours. Because once I figure that out, all I have to do just write it into that blank spot. When did the max occur? What month? June corresponds to which number? 6. June, 6 month. Yes. Okay. So then that's it. That's my phase shift. It's 6. So then I just do a minus 6 and I'm done. That is my equation. That is my equation. Now, if you wanted to write, let's say you wanted to write the B already factored in, okay? Y'all said it was 2.9, not 29, right? It was 2.9? Okay, I missed the dot for whatever reason. Now, if you want to, you can easily distribute the B in and get minus pi as your equation. Either one is still correct. Either one is still correct. If you wanted to do it the other way, once you found out that your phase shift was 6, you could set that equal to negative C over B. You found that B was pi over 6. Multiply both sides, and you'll basically get 6 times pi over 6, which is just pi. So C is a negative pi. Like, you could have done it that way, too. It's still the same thing. So either one is the equation to represent the number of hours of daylight in New York City. Questions on how we got the equation?
I don't know how we got it, but like the pi over 6 in the first equation, that still affects your x, right? It wouldn't affect your y.
Correct.
It's outside of the...
Correct. It still affects your x, yes. Now it says to use your model to estimate the number of hours of daylight on September 30th in New York City. Well, in this case, x is equal to 9.5. So then that means we need to plug in 9.5 to figure out the number of hours. This is straight in your calculator, okay? This is straight in your calculator. So go ahead and type in 2.9 cosine. You can do either form, or it really doesn't matter. Pi divided by 6. Be careful. When you type cosine, a parenthesis will pop up. Okay? If you do pi over 6 without parentheses, then I suggest that you use the first equation. Do 9.5 minus 6, then you can close it off, plus 12.17. You type that into your calculator. I do have 2 parentheses at the end of that 6 because one, the first parenthesis closes off the 9.5 minus 6. The second parenthesis actually closes off that entire pi over 6 times that number. Then the plus 12.17. Has everyone typed it in? Did you guys get this number? Okay. If you did not get this number, that means your calculator, and you typed in exactly how I have it, that means your calculator is in the wrong mode. Right beside your second button is a button that says mode. You press that button. And if you look, there's a line that says radian and degree. You want to scroll down to that line, and you want to make sure that radian is highlighted. If you did not get that number, that meant that degree was highlighted. Okay? So to get to radian, you just move it over to where it's flashing over radian, and you click enter. Okay? Because in this case, isn't pi over 6 a radian? It's not a degree. So you need to let the calculator know I'm dealing with radians and not degrees. Okay? So if you press second mode, it gets you out of that screen. Okay? And you can either press enter to get the entire thing that you just typed back in, and then it'll give you that number. Okay. So how many hours of daylight? It'll be 11.4. All right, let's look at the next one. Okay? The average monthly temperatures for Seattle, Washington are shown. There is an error. If you look at the month of May, it just has 6. That should be a 56. Okay? Should be a 56. We're going to write a function that models the monthly temperatures using x equal 1 to represent January. Okay? So then that means this is 1, so on and so forth. Just like before, to write our equation, we need to determine what's our maximum temperature, what's our minimum temperature. What's our maximum temperature? 66. I have it in August. What's my minimum temperature? January, 41. Okay? So, I can find my A, right? What's the formula? Max minus min over 2. That's how I can get my A. $12.5? Yes? All right, we got 12.5. Now let's find D, because you might as well just find both pieces because it's the same number. You just got to change the signs. So 66 plus 41 divided by 2. 53.5. Okay, we're halfway done to write the equation. What should I find next? B. That's the formula 2 pi over B. That should equal what concept? 2 pi over B is the formula for what?
Period.
Let's find my period. The distance between my minimum value and my maximum value is how long? 8. This is what I was talking about. You got to base it off of the data. Okay? So even though you are dealing with just data for the first year or whatever like that, you can't automatically assume that it's 12, because in this case, from max to min, that's 8, right? That's half of your period. So to get the whole period, you do what? Multiply by 2 is 8 times 2.
16.
So this is going to be 2 pi over b is equal to 16. I am going to solve for b. And b equals pi over 8. What is my phase shift? How long does it take for me to reach that maximum temperature? What month does it reach the maximum temperature? August. August corresponds to what number? 8. So my phase shift is 8. And if I write it the way I wrote the last one, I'm done. Right? So I'll have y equals, remember we're basing off of cosine. So I have y equals 12.5 cosine pi over 8 x minus 8 plus 53.5. That's my question. Questions? Now, according to my model, what is Seattle's average monthly temperature in February? Yes, we do have February already, but it's set according to our model. So we're going to see how good of a model that we have by plugging in what number?
144.
No. Plugging in 2 to get a temperature to see how close to 44 we are. Okay? So, this is part A. Part B, I actually need to plug in two, which represents February, to see how close of a model I have. Did you guys get this? 44.7 degrees, something, doesn't say, 5 degrees Fahrenheit. Not bad. I mean, it's set for 44, so, you know the, weather people never give you like the decimal degree, so, not too bad. How is this? I'm going to leave that next data one for you guys to do for your homework, okay? But it's talking about high tide, and you have to just write a function to represent the heights of the high tide, okay? But let's get to ones that aren't data-based, okay? Let's get to ones that aren't data-based. We have boating. Do you guys have that example? Now it says a buoy bobbing up and down in the water as waves pass it moves to its highest point, to its lowest point, and back to its highest point every 10 seconds. The distance between the highest points and the lowest points is 3 feet. The highest and lowest. Okay? We have to determine the amplitude and the period of the sinusoidal function that models the bobbing buoy. And then we're going to write the equation of the sinusoidal function that models the bobbing buoy using x equals 0 as its highest point. First off, does everybody know what a buoy is?
It's a boat.
Not a boat, but it's like a little object in like the ocean that kind of lets ships know that, hey, don't come past this point because we got like people swimming. That's what a buoy is. Yeah. It's like a little red and white thing, and it's literally like just sits in the water, and it just goes up and down, like it just bobs up and down. Doesn't that look like our sine function? That's what I mean. It's a terrible looking buoy. First off, and it's definitely not the best way. Okay, so there's your buoy. There it is in water, and what you see in the pinkish purple color is basically the representation of the buoy bobbing. Okay, it does create a sinusoidal curve. It does. Okay, now it says here it goes from its lowest point, its highest point, to its lowest point, and back to its highest point every 10 seconds. What do you think that 10 seconds represents?
Period.
It represents the period because it goes from highest point to lowest point back to this highest point in 10 seconds. That is one complete cycle. So 10 represents our period. Now it says the distance between the highest point and the lowest point is 3 feet. So that means from here to here, that distance is 3 feet. If that distance from my highest point to my lowest point is 3 feet, then what's my amplitude? Say again? 1.5. It is halfway, because remember, there's a midline there. So you have to cut that in half. So you guys have found my information. My amplitude is 3, and my period is 10. So you see how we were able to pull out that information from the description? You don't need data. You just got to be able to use your deductive reasoning skills to pull out the information.
Amplitude is 1.5.
Ooh, thank you. Sorry, amplitude is 1.5. Good catch. Got a little excited. Because it's half. Now we need to write an equation that models the bobbing buoy using x equals 0 as its highest point. So since it told us that our highest point is at 0, this is basically your graph right there. The max is already on the y-axis. So do I have a phase shift? Do I have a vertical shift? Because remember, this was 1.5 above, 1.5 below. So I have a vertical shift. All I have is an A and a B. Amplitude that deal with my amplitude and my period. Okay? I'm underlining those key points, those key features. So let's write my equation. I already know what A is. What's A? 1.5. This is the cosine function. Now the last thing I need is my B. How do I find it? I said 2 pi over b equal to 10. So that becomes 2 pi equals 10b. So what is b? So pi over 5, and then don't forget your variable x. And boom. That's the equation. Questions? Let's do one more, and then the remaining other 2 problems. Let's actually do this one. Let's do the roller coaster. So then swimming, the swing one, the Ferris wheel, that would be, and then the other data one will be the one that you have to do for homework. Okay. Okay, so part of a roller coaster track is a sinusoidal function. The high and the low points are separated by 150 feet horizontally and 82 feet vertically as shown. The lowest point is 6 feet above the ground. Okay? Now it says write a sinusoidal function that models the distance the roller coaster track is above the ground at any given horizontal distance x. So in other words, write your function, okay? And as you guys can see here, this is basically modeling a, our function here. You guys see it? Okay? So, again, easiest thing to write is the cosine function. As we can see, the highest point on the track is given to us on the y-axis, okay? Excuse me. Now, exactly what is the highest point, though? How high is that highest point? Now, 82 feet separate the highest and lowest points, but the lowest point is 6 feet off the ground. So what is that? What is that full distance right there? No. It's 88 because it says from the ground, okay? Above the ground. So, yes, this point here is actually at 88 feet, okay? Now, the lowest point is where? At 6 feet. So, my max is 88. My min is 6. So, I can find my A and my D, right? Max minus min divided by 2 will help me find my A. What's 88 minus 6 divided by 2?
43.
40 what?
3.
43 minus 6. That will give me 41. Because it'll be 82. 82 divided by 2. And then if I did 88 plus 6 divided by 2, what will that give me?
47.
That will give me 47. Okay? So now I have my A and I have my D. Okay? Now I need to figure out my B. Now B is associated with period, like we've been talking about. Okay? What is my period? How long is one complete cycle of this track? Say again? It's 300. Because from max to min, that's a total distance of 150 feet. So if I have half of a cycle, I just have to multiply it by 2 to get my full cycle, which is, yes, 300 feet. So my period is 300. So then to find B, I just have to set that equal to 2 pi over B. So that give me 300B equals 2 pi. B is equal to what?
Good morning, Ms. Anderson.
So what is that when I solve for B? Pi over 150. Pi over 150. Do I have a phase shift? No, I don't, because my highest point starts on that y-axis. So I have my equation. Y equals 41 cosine pi over 150x plus 47. And that plus 47, that is on the outside, so that represents my D. I don't have a C, I don't have a phase shift. Now it says that point A is 40 feet to the right of the y-axis. It is 40 feet to the right of the y-axis. How far above the ground is the the track at point A. So if you think about it, it's 40 feet to the right of the y-axis. So 40 feet, you have some point A that's on the track. It's asking you to find basically the y value. How high above the ground is that point? So what do I need to do with the 40? Plug it in for x, because x represents my distance of the track, on the track, and y represents my height. So that's 41 cosine pi over 150 times 40 plus 47. I'm going to use my calculator. I'm going to type that in, of course, making sure I am in radian mode, which you guys should be, because you shouldn't have changed it. But if your number doesn't look right, or maybe it's negative, or maybe it's a decimal, that might mean that your calculator's in degree mode. So we got 74.4 feet, which makes sense, because since the roller coaster is going down, it should definitely be less than 88, okay? And it's not too far along the path, so it should definitely not be nowhere near the 6 feet range, okay? But that's how you apply all of our properties from the graphing of sine and cosine and the writing of the equations to apply it to your application problems, okay? The rest of them are on you.